Welcome to Purdue Global Academic Success Center's presentation on electrons. The learning outcomes are to review the following: the discovery of the electron, model of the atom, the Bohr model, the quantum mechanical model, atomic orbital, maximum number of electrons, electron arrangement in atoms, Aufbau principle, Pauli exclusion principle, the quantum mechanical model, and the conclusion. Discovery of the electron. During the 1880s and 90s, scientists searched cathode rays for the carrier of the electrical properties in matter. Their work culminated in the discovery of English physicist J.J. Thomson of the electron in 1897. J.J. Thomson's experiments with cathode ray tubes showed that all atoms contained tiny, negatively charged subatomic particles, or electrons. Thomson proposed the plum pudding model of the atom, which had negatively charged electrons embedded within a positively charged soup. Now, let's review what an electron is and a little bit about its discovery. The electron is a low-mass, negatively charged particle. As such, it can easily be deflected by passing close to other electrons or the positive nucleus of an atom. The electron was the first fundamental particle that was discovered. The credit for that discovery of the electron and its properties go to J.J. Thomson. The characteristics of electrons are the following. The smallest unit in the composition of matter is the atom. The atom is composed of a nucleus at the center and one or more electrons orbiting around this nucleus. The nucleus consists of protons and neutrons, collectively called nucleons. The protons are positively charged particles with a mass of 1.00728 AMU, and the neutrons are electrically neutral particles with mass of 1.00867 AMU. The electrons are negatively charged particles with a mass of 0.000549 AMU. The protons and neutrons are about 1,836 times heavier than the electrons. The number of electrons is equal to the number of protons, thus resulting in a neutral atom of an element. The electronic arrangements determine the chemical properties of an element, whereas the nuclear structure dictates the stability and radioactive transformation of the atom. Models of atoms. Rutherford used existing ideas about the atom and proposed an atomic model in which the electrons move around the nucleus like the planets move around the sun. However, Rutherford's model fails to explain why objects change color when heated, and Rutherford's atomic model could not explain the chemical properties of elements. In 1863, John Dalton pictures atoms as tiny, indestructible particles with no internal structure. In 1897, J.J. Thomson, a British scientist, discovers the electron. This later leads to his plum pudding model, where electrons are embedded in a sphere of positive electrical charges. The Bohr model proposed that an electron is found only in specific circular paths, or orbits, around the nucleus. Each orbit has a fixed energy. These fixed energies an electron can have are called energy levels. To explain it with an analogy, think of a ladder with rungs that are not equally spaced apart. These ladder steps are somewhat like energy levels. Like the rungs of a strange ladder, the energy levels in an atom are not equally spaced. The higher an electron is on the energy ladder, the farther it is from the nucleus. Quantum of energy is the amount of energy required to move an electron from one energy level to another energy level. The higher the energy level occupied by an electron, the less energy it takes to move from that energy level to the next higher energy level. Now, let's take a closer look at the Bohr model. To move from one energy level to another, an electron must gain or lose just the right amount of energy. The higher an electron is on the energy ladder, the farther from the nucleus. The Bohr model establishes the concept of definite electron energy levels within atoms. But Bohr's model was rather simplistic, and as scientists made more discoveries about more complex atoms, Bohr's model was modified and eventually replaced by more sophisticated models. In 1926, Erwin Schrödinger developed mathematical equations to describe the motion of electrons in atoms. His work leads to the electron cloud model seen in the figure. The modern description of the electrons in atoms, the quantum mechanical model, comes from the mathematical solutions to the Schrödinger equation. Like the Bohr model, the quantum mechanical model of the atom restricts the energy of electrons to certain values. Unlike the Bohr model, however, the quantum mechanical model does not involve an exact path that the electron takes around the nucleus. Instead, it determines the allowed energies an electron can have and how likely it is to find the electron in various locations around the nucleus. Here is a quantum mechanical picture of a hydrogen atom. The nucleus is not shown but is located at the center of the picture. Like the heads, you can see where the electron is most likely to be near the nucleus, which is at the center of the picture. You can't tell exactly where the electron is, just where it is most likely to be. The individual dots are not electrons. They are meant to be used in the context of how dense or heavy an area of dots appears. The more crowded or heavier packed the dots are in a particular region, the better chance you have to find your electron there. An atomic orbital is often thought of as a region of space in which there is a high probability of finding an electron. Each energy level corresponds to an orbital of a different shape, which describes where the electron is likely to be found. The numbers and kinds of atomic orbitals depend on the energy sublevel. The lowest principal energy level, n equals 1, has only one sublevel, called 1s. The second level, n equals 2, has two sublevels, 2s and 2p. Thus, the second energy level has 4 orbitals, 2s, 2px, 2py, and 2pz. The third level, n equals 3, has 3 sublevels, 3s, 3p, and 3d. Thus, the third energy level has 9 orbitals, 1 3s, 3 3p, and 5 3d. The fourth level, n equals 4, has 4 sublevels, 4s, 4p, 4d, and 4f. Thus, the fourth energy level has 16 orbitals, 1 4s, 3 4p, 5 4d, and 7 4f orbitals. Maximum number of electrons. This is an arrangement of electrons in various shells, subshells, and orbitals in an atom. It is written as 2, 8, 8, 18, 18, 32, which can be annotated as NL to the x, where n indicates the principal quantum number, L indicates the azimuthal quantum number, or subshell, and x is the number of electrons. Electron arrangement in atoms. The ways in which electrons are arranged in various orbitals around the nuclei of atoms are called electron configurations. The 3 rules, the Aufbau principle, the Pauli exclusion principle, and Hund's rule, tell you how to find the electron configurations of atoms. According to the Aufbau principle, electrons occupy the orbitals of lowest energy first. The Aufbau principle states that electrons fill lower energy atomic orbitals before filling higher energy ones. Aufbau is German for building up. By following this rule, we can predict the electron configurations for atoms or ions. Pauli's exclusion principle states that no 2 electrons in the same atom can have identical values for all 4 of their quantum numbers. In other words, no more than 2 electrons can occupy the same orbital, and 2 electrons in the same orbital must have opposite spins. The Pauli exclusion principle helps explain a wide variety of physical phenomena. One particularly important consequence of this principle is the elaborate electron shell structure of atoms and the way atoms share electrons, explaining the variety of chemical elements and their chemical combinations. According to Hund's rule, every orbital in a subshell is singly occupied with 1 electron before any one orbital is doubly occupied, And all electrons in singly occupied orbitals have the same spin. All the unpaired electrons have the same spin. Then, a second electron with an opposite spin completes the occupancy. For example, the electron configuration for a carbon atom is 1s squared, 2s squared, 2p squared. In this seminar, we learned Thomson described the atomic structure as a positively charged sphere into which negatively charged electrons were embedded. Electrons play an essential role in numerous physical phenomena such as electricity, magnetism, chemistry, and thermal conductivity, and they also participate in gravitational, electromagnetic, and weak interactions. And an electron is a negatively charged subatomic particle that can be either bound to an atom or free, not bound. An electron that is bound to an atom is one of the three primary types of particles within the atom. The other two are protons and neutrons. Together, electrons, protons, and neutrons form an atom's nucleus. Thank you.